All right, we're going to talk about using linear models today. And so we're going to talk about scatter plots. So scatter plots is just plotting all your data and kind of seeing where it lies on the graph. When we look at these, we're going to look at, is there a correlation or is there a relation between the data sets? So we have different types of correlation. So we have what we call a strong negative correlation. So negative just means that the values from left to right are going down. So this would be a strong negative correlation. It means that the data values are kind of close together. They have this negative slope kind of idea. We have a weak negative correlation. So they're still going down, but they're not quite as compact or compressed together. And then we have no correlation. No correlation means that there isn't any relation between the data points. It almost looks like a circle type of thing. We have strong positive correlation, so the values are kind of compact together. They're rising to the right. We have a weak positive correlation. They're still rising to the right, but they're not as closely compact. So the next thing we're going to do is we're going to kind of look at making a scatter plot and then making a trend line. So a lot of times when we're looking at data, what we're going to do is we're going to plot that and then we're going to kind of see what is the best fit for it. Does it look like it's a linear equation that could help us predict future values? Would it be maybe a parabola? So what we're going to look at here is just finding a linear model that represents this data that would get me close to it. It's not going to get me exact because if you notice here that I have some values that I have duplicate x's on. So the first thing I'm going to do is I'm going to plot all this information. So here's my grid. I'm going to go 0, 1. There's my first one. 1, 3, 1, 2. 3, 5, 2, 3, 1, 2, 3, 4, 5, 4, 7, 4, 7, 5, 3, 5, 3, 6, 7, and 6, 6, and then we have 8, 8. So as I look here, hopefully you can see these points here. I'll make them a little bigger. It looks like they have a kind of a positive correlation. So they're kind of rising to the right. Now we do have this one here, this 5, 3. It's kind of a little offshoot. And so what we're going to do, so that's my scatter plot. Okay. We don't know what these have entitled. Maybe this is, running distances and times and this person tripped and fell, so they had or ran only a short distance and then walked. So we don't know, we're just plotting the values. Now, when we make a trend line, what we want to do is take a ruler or a straight edge to our scatter plot, and what we're trying to do is we're trying to get half the data above that line and half the data below it. And we're trying to get it to where the distance is, if I were to add up all the distances from the point to the line, they're going to be the same or very, very close to the same. Okay, so this one does kind of throw it off here. We're just going to kind of do a hands-on approach to this. There are, obviously, if you were going to do this for research and stuff, you're not going to do it by hand. You're going to actually use a computer program and find the line of best fit. And it's going to give you the line where all these distances are the smallest, okay? So we are doing it by hand, so we're kind of doing a little bit of rough. So here I have my straight edge, and I kind of look here, and I want to kind of look to get into a position where I have, maybe half the data above, half the data below. So here I have 3 above and 3 below. It looks like that if I were to draw a line connecting these ones right here, I would have 3 above, 3 below, there is a little bit more distance here on the bottom. That's okay for our purposes right now. We're just trying to get an idea. So actually what I might do too is I might kind of take this and go, well, I need these distances to be here. So maybe I put it here. I'm gonna put this little dash line here. Okay, and now the distances would probably be closer. And what you're going to do is you're going to pick 2 lines, 2 points that are close to the line. Okay, so if I were picking, the dash line, I'd probably use this one and this one, so it'd be a little bit different. But I'm going to pick this point here and this point. So this is the point 1, 2, and I'm going to pick the point 6, 7. And so now what I'm going to do is I'm going to actually find the slope between those. So I'm going to find my slope, 7 minus 2 over 6 minus 1. That gives me 5 over 5. Awesome, that's a slope of 1. Now I'm going to use these, and I'm going to use if you remember from the previous lesson, we're going to use point slope. So y minus y sub 1 equals our slope, x minus x sub 1. Doesn't matter which one of these you pick one. I'm going to pick this one. Y minus 2 equals, I'm going to write in my slope here, even though it's 1, just so you guys can see it. X minus 1. There is my equation of the line. If I wanted to solve this for y equals mx plus b, I could do that. Y minus 2 equals, I'm going to distribute my 1, x minus 1, add my 2 over, y equals x plus 1. There's my equation of the line. Okay? Now, this is a pretty simple approach and very simple coordinates here. Sometimes this slope might be very difficult, and it would be very difficult to solve this into y equals mx plus b. You might need to leave it in point slope form because your slope might be something like 2,375 over 138. And so to multiply that through and adding them might be difficult. But hopefully that gives you a little bit better idea. If we want precision, we're going to go use a computer program. Okay? So that's linear models, scatter plots, correlation, how to find a trend line by hand. It's not as precise as using a computer program, but we're just going to do it by hand.